Alright guys, today we're going to look at the quadratic formula. Quadratic formula. When a quadratic equation cannot be solved by factoring, we can find the roots by using the quadratic formula. Now this will always work. Okay, so if you want to factor it, you can. Okay, if it's factorable obviously. But you can always use a quadratic formula and you will get the correct answer. So if you want to use the quadratic formula for anything, okay, you can. You can use it if it could be solved by factoring, if it could be solved by the square root method, if it could be solved by graphing. All of these will give you the same answer if you use the quadratic formula. Alright, so this is a foolproof way to solve quadratics. Alright, so let's look. I've got negative b plus or minus the square root of b squared minus 4ac over 2a. Now what is a, what's b, what's c? Let's remember our standard form, right? A is the coefficient in front of the x squared, b is the coefficient in front of the x to the first term, and c is the constant at the end. So it's going to be very critical that you identify in your examples and in your questions what is a and what is b and what is c. So in this case, we're looking at number 1. A is the coefficient in front of x squared, which is 1. B is negative 2. And c is positive 4. So what we're going to do is we're going to plug these values into this formula. So this is negative b. So it's negative, and now I'm going to plug in b. Well, b, I'm plugging in this for b, so negative 2. Plus or minus the square root of b squared. So again, I'm plugging in b, which is negative 2 squared, minus 4 times a, which in this case a is 1, and c is 4, over 2 times a, which is 1. Okay, so that's how we set up the quadratic formula. Now 1, 2, 3, and 4, all we're doing is we're setting it up. Now again, it's important to note this is negative b, so when I plug in b in this right here, that's an opposite of a negative b, so it's going to give me a positive 2 right here. Okay, let's look at number 2. Let's identify a, b, and c. A is 2, b is negative 3, c is 1. So we've got negative b, so negative 3, or the opposite of b, plus or minus the square root of b squared, minus 4 times a, which is 2, times c, which is 1, over 2 times a. Number 3, again, I have a coefficient of 1, 3, and negative 7. So I've got negative b, so negative 3, plus or minus the square root of 3 squared, minus 4 times 1 times negative 7, over 2 times a. And last one here, we've got a coefficient of 3. b, I don't have a b term. I don't have an x term. So b would be 0 in this case. And c would be 10, because that is my constant. So it's negative 0 plus or minus the square root of 0 squared minus 4 times a, which is 3, times c, which is 10, over 2 times 3. So in this case, this is 3x squared plus 0x plus 10, if I was to write it in standard form. Alright, let's go to the back. We have what we call the discriminant. So in the quadratic equation, the discriminant tells you what type of roots the quadratic has. Alright, so b squared minus 4ac, b squared minus 4ac, that should look familiar because that comes from the quadratic formula. Right? If I go back to the front, the quadratic formula, b squared minus 4ac, is what's underneath the radical. We call this the discriminant. And that tells us what type and how many roots we have. So if my discriminant is greater than 0, I have 2 real roots. If my discriminant equals 0, I have 1 real root. And if it's less than 0, or we could say this is negative, if I get a negative inside of my radical, I have no real roots. We have an imaginary solution. Alright, so if the discriminant is positive, it's greater than 0, we have 2 solutions, or 2 x-intercepts. If the discriminant equals 0, we have 1 solution. And if the discriminant is negative, if I got a negative underneath the square root, then it is no real solutions. Alright, so here we go. It says write each equation in standard form, substitute a, b, c, and d, or sorry, a, b, and c, and then find the value of the discriminant. So we got a in this case, 1, negative 8, and we need to move this 15 to the other side. So in standard form, this would be x squared minus 8x minus 15. So c is negative 15. Alright, so now I'm going to plug in negative 8, so negative b plus or minus the square root of b squared, negative 8 squared, minus 4 times a times c over 2 times a. Alright, so here we go. All I'm looking at is the discriminant right now. So I've got 8 squared, negative 8 squared is going to give me a positive 64, minus 4 times 1 times negative 15. So negative 4 times 1 is a negative 4, times negative 15 is a positive 60. So I know that I get the square root of positive 124. So again, let's go back up here. If my discriminant is positive, I have 2 real solutions. All I'm looking at is the discriminant here. I'm not solving, all I'm looking at is the discriminant. Same thing for number 2. A is 1, negative 5, positive 20. So I've got negative 5 plus or minus the square root of negative 5 squared minus 4 times a times c over 2 times a. So let's look at the discriminant to identify how many solutions we have. We've got positive 25 here, minus 4 times 1, which is 4, times 20, which is 80, so minus 80. Well, that's going to give me a square root of a negative 55. So if it's square root of a negative number, we have no real solutions. No real solutions. What that means is that does not cross the x-axis. Alright, 2 more. Let's go to number 3. So number 3, again, I want to identify a, b, and c. So this is 3x squared. I need to move this to the other side, so positive 5x. I need to move this to the other side, so positive 2. So 3x squared, this is a b, which is 5. This is c, which is 2. So negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So let's look at the discriminant. We've got the square root of 25, because 5 squared is 25, minus 4 times 3 is 12, times 2 is 24, so minus 24. Well, that's the square root of 1. That's positive solution, so I have 2 real solutions. Last one here, we've got 1, negative 8, positive 16. So negative 8 plus or minus the square root of negative 8 squared minus 4 times a, which is 1, times c, which is 16, over 2 times 1. So let's look at my discriminant to identify how many solutions we have. This is going to give me a positive 64. This is going to give me negative 4 times 1, which is negative 4, times 16, which is a negative 64. So the square root of 0. Again, the square root of 0 is equal to 0. So my discriminant equals 0. I know I have 1 real solution, which means that my vertex lies on the x-axis.